October 30th, 2025, flying above the clouds at an altitude of 37,000 feet, hundreds of passengers' lives depended on a device that had malfunctioned. The result was that despite the pilot's efforts, this faulty system was forcibly pushing the plane's nose down. This caused the plane to rapidly descend toward the ground. This was an Airbus A320 model aircraft operated by JetBlue. It was supposed to fly from Mexico to New Jersey, but suddenly, this plane began plummeting downward. According to Flight Radar 24 data, this plane was descending 100 feet every 7 seconds. This speed was so fast, folks, that several passengers were injured by hitting the seat in front of them. The pilot somehow controlled the plane and managed to land it at the nearest airport, Tampa International Airport. About 15 people were injured, but the good news is that no lives were lost in this incident. Now, the investigative team began trying to figure out exactly what went wrong with this plane that caused the nose to suddenly pitch down. Initial investigations found no evidence to prove that the pilot had done this. After nearly a month of investigation, the result that emerged was shocking because the problem was such that the entire aviation industry could be in danger. More than 6,000 planes could have this same problem that occurred with JetBlue Flight 1230. Actually, in the JetBlue flight, the flight control computer that controls the plane had become corrupted. To understand this problem, we need to understand Airbus's basic controls. Normally, planes have a yoke that's connected through cables, pulleys, or hydraulics. Due to this connectivity, when pilots move the yoke left and right, the ailerons on the plane's wings move up and down. This causes the plane to roll. Similarly, every control is physically connected. Even our car's wheels are connected to the steering wheel in this same way. But Airbus uses different technology in their planes. We know this as fly-by-wire technology. Their controls aren't connected by rods or cables, but are connected to computers. That's why Airbus uses just a small joystick to control such large planes. Anyway, when the pilot gives an input on the joystick, or rather the side stick, an electric signal travels through wires to the ELAC. ELAC means Elevator Aileron Computer. This is a computer that studies the command given by the pilot. It calculates it. If the pilot pushes the side stick down slightly, the ELAC will lower the nose slightly. If the pilot pushes down a bit more, the ELAC does all the calculations and lowers the plane's nose a bit more. But even this has a limit. Beyond a certain limit, the plane's nose cannot be pushed down further. Suppose if a pilot intentionally wanted to crash the plane, or if an unknown person entered the cockpit and wanted to crash the plane by pushing the nose down, after a certain limit, the ELAC would say, "Hey, we're not going to let you push the plane's nose down that much. Something's wrong here." That's why in such cases, this ELAC can work against the pilot as well. We can call this the brain of the plane. On October 30th, 2025, this same ELAC malfunctioned on the JetBlue flight. The ELAC has a unit called ELAC-B, in which software version L104 was installed. This same software had a problem. In today's era, all planes depend on automation. In such a situation, software malfunction or data corruption could put hundreds of lives in danger. Therefore, an investigation was conducted into how the ELAC software malfunctioned. Once again, a shocking revelation occurred because the cause of this malfunction was the sun. The sun periodically releases solar energetic particles containing highly charged protons and electrons that spread in all directions at nearly the speed of light. This radiation can be very harmful to our Earth, but Earth has its own magnetic field. Earth has its own atmosphere that filters these radiations, so we get as much sunlight as we need. But when planes are at high altitude, sometimes the sun's radiation corrupts the aircraft's electronics. This is called a single event upset, or SEU. This problem occurs when high-intensity solar particles come in contact with the computer chip. They strike the computer chip. This impact causes a bit flip. As we all know, computer language is in the format of zeros and ones, and these solar particles cause bit flips, changing a 0 to a 1 for a few moments. This is why JetBlue's software L104 malfunctioned. This could happen to other Airbus A320 model planes as well. Therefore, keeping safety in mind, Airbus made a very big decision. More than 6,000 planes were called back so that all plane software could be changed from L104 to L103+. Plus. This update can take 3 to 4 hours per plane. Meanwhile, older model planes could face considerable difficulties because hardware might have to be changed. In India, too, the DGCA has ordered the update for Airbus. The biggest impact in India will be on Indigo Airlines because I think Indigo is the only airline company in the entire world that uses the most Airbus A320s. Now, we have to see when all these updates will be completed. Now, you might also be wondering what the solution to this is. How can planes be protected from this kind of solar radiation? Well, the answer is by using EDAC technology. EDAC means error detection and correction. The name itself is clear. It will first detect the error and then correct it. But how will this work? Well, suppose the pilot here sent an electric signal. Let's say that signal is 1001. In such a case, if solar radiation contacts the computer, it might change a 0 to a 1 and cause a software malfunction, just like what happened with JetBlue. Now, what this error detection and correction system does is send the 1001 signal 3 times. In such a case, if a charged particle changes a 0 to a 1, it can only change one 4-bit block. The other 2 blocks will remain intact. Now, obviously, 2 blocks are the same, so the malfunction must have occurred in the different block. And in this way, the error is detected, and the command given by the pilot also reaches the control surface safe and sound. This EDAC was also installed in the Airbus A320 when the JetBlue software glitched. Now, why didn't this system work? There's no information about that for now. Maybe there was some problem with the new software L104 that Airbus had installed, which is why L103 Plus is being installed in more than 6,000 planes again. That is, the software version is being downgraded. At least Airbus is doing something about safety. You might remember that Boeing also installed a system called MCAS in their planes, and this system was pushing the plane's nose down while pilots were pulling the yoke back trying to lift the plane up, which caused the Ethiopian Airlines crash. Yet Boeing remained silent. Many reports even claim that Boeing's engineers knew everything, but still they remained silent, and another plane, Lion Air, also crashed. This is why, folks, Boeing's image, built over decades, is gradually deteriorating because a lot of safety issues are being seen with Boeing. Meanwhile, looking at Airbus as such a big decision, it seems that Airbus is very active about their safety. If you liked this video, you can watch this video too. That's all for now in today's video.